So we're going to talk about the stress response and also the sickness response. And first we need to separate stress into different components. It's easy to just talk about stress and just mean everything by it, but I would like us to separate it into stressors. And stressors, they are actual or anticipated threats to the organism, and that could be a bear, for example. Meeting a bear, thinking about meeting a bear, or actually meeting a bear doesn't matter. Both are stressors, and it doesn't need to be something as bad as running into a bear. It could be high noise, and it could be an infection. All of these things are stressors, and it's up to the brain to decide what is a stressor. And that means that we can imagine stressors, which is very stressful, or interpret situations very differently as stressors or not, depending on what we've been through in our lives before. And when the brain realizes that there is a threat, we will have a stress response. And the purpose of the stress response is to, I will just move you out of the way. The purpose of the stress response is to manage the threat and support recovery. And during the stress response, we have the support of two stress axes. We will have the sympathetic nervous system, which is part of the autonomic nervous system. This is what you would feel immediately when you're stressed. It's due to the release of noradrenaline and adrenaline, and this response is within seconds. And then we have a slower stress axis called the hypothalamic pituitary adrenal axis, the HPA axis. This will lead to the production of cortisol, and this is a much slower process. But both of these axes, they aim to mobilize energy and resources so that we can manage the stress, the threat that we're facing. And at the same time also inhibit those body functions that we don't need for the immediate survival. So looking closer at the autonomic nervous system, we have the sympathetic nervous system part here and the parasympathetic nervous system right here. They are part of the autonomic nervous system. They work a bit like a yin-yang, that they balance each other. The autonomic nervous system, consisting of these two parts, regulates bodily functions. And you can see all the organs here being innervated, both these nervous systems. This is something that is largely unconscious. So even though we can think about our heartbeat, we don't regulate the heartbeat consciously, at least not all the time. Breathing, same thing, that we don't need to think about breathing. We might be able to control our breathing, but we don't normally think about it. And then we have other things bodily processes that we don't think about, like digestion and the production of urine and sweating, for example. So what happens throughout the day is that we have a balance between the sympathetic and the parasympathetic nervous system. The sympathetic nervous system we usually call the fight, flight, or freeze response, while the parasympathetic nervous system gives us the rest and digest response. But it's very important to recognize that these systems are in balance throughout the day, and we need the sympathetic nervous system just to get out of bed in the morning and just to function normally. So this is a balance going back and forth. What happens when the sympathetic nervous system is activated is that the heart rate goes up, the blood pressure goes up, respiration and perspiration goes up. You can see that the eyes becomes blacker because the pupils they contract so that you get more light into the eyes. We get more blood flow to muscles. The attention is increased. But we don't care about digestion and reproduction in this situation. And this is a very, very useful response if you manage to bump into a bear. when you're out walking in Yosemite. So this is the immediate response that we get. We also get the activation of the HPA axis. And the HPA axis will release cortisol. Cortisol is a much slower acting hormone. It actually changes what genes are expressed in cells. And that means that cortisol will change the cell to the core, so what function the cell actually has. So much slower response that influence function over time, and this is vital also for recovery. You need to at this stage, when you have the highest amount of cortisol, is when you need to recover. So when you need to replenish the energy sources, for example. So important, talking about long COVID, is the inflammatory reflex. Because why are we talking about this? Yeah, so here we got the HPA axis, the release of cortisol, and the acetylcholine and adrenaline, noradrenaline that we talked about. And this is an immune cell. So the brain uses the stress axis to regulate the immune system. And the immune system use the sympathetic nervous system, or the parasympathetic nervous system, the nervous system to signal back to the brain what is actually happening in the body. So when we have an infection, the immune cells will release what we call pro-inflammatory cytokines that will signal to the brain. And when this happens, we will develop a range of symptoms that you probably will recognize. We will experience fatigue, increased sleep. We will feel depressed. We won't like to interact socially with other people. We feel anhedonia, and that means that we don't get pleasure out of things that normally pleasures us. Allodynia means that the body gets sore to the touch, so you don't feel pain, but when you touch your skin, you will feel pain. And also developing a fever or feeling cold. And this is a strategy that we have developed with evolution, because it means that we will keep ourselves safe when infected or when during threats. And it also will save energy, because the immune system takes a lot of energy, so we need it. So it's not just a weakness, this is actually a motivational state to survive, to increase survival. And what happens if things become out of the ordinary, like when you face that bear every day, or the equivalent of facing the bear, with the multiple activations of the stress axis will result in a toll on the system. Or in this case, this example here is when you don't adapt. So you keep activating the stress axis. And eventually you might get into a situation where you can't go back to normal anymore, or where you just can't mount an appropriate response to the threat you're facing, whatever it might be. And the thing is, when we get into a situation where the stress and the sickness response are not adaptive anymore, because they are all interlocked. So if some part gets downregulated and some part gets upregulated, it will all become out of sync. So this is some sort of schematic here of how all these systems are intertwined with the brain, the central nervous system, the cardiovascular system, the immune functions. So if it can become problematic, and then the general rules on how the physiology works doesn't apply anymore.